I just wanted to create one more video about what you should have on your note card. So on your note card for this week's quiz, you need to have, I would say you would want formulas for the two situations you have. You have hypothesis testing for proportions with one sample. And then you'll also have hypothesis testing for proportions with two samples. So these are the two types of problems that you will encounter this week. And you will want the appropriate formulas for each of these. So when doing hypothesis testing for proportions with one sample, your null hypothesis will always be p equals some value here. So I'm just going to put in for stand-in, I'm going to put in 0.30, okay? But of course, but whatever value is listed in the problem. And then the alternative will be identical to that, except it's going to be p either not equal to 0.30 or p greater than or p less than, okay? So your choice of not equal, greater than, or less than depends on the question. Okay? It's good to note that your standard error is going to be P0, the value in your null hypothesis in this case would be 30%, times 1 minus P0 over n, or P times 1 minus P over n, using whatever P is in your null hypothesis. Your test statistic Z is going to be P hat minus P0, whatever value is in your null hypothesis, divided by the standard error. P hat is the sample proportion. It might be given to you directly in the problem. It might say you took a sample and 25% of your sample had this. That would be your P hat. It might list it off as y over n. You might have to say you took a sample of size 100 and 25 people in that sample had this, and then you have to do 25 over 100 to get your p hat. So you would need your test statistic, and then you would find your p-value, okay? And your p-value is found by looking up the z-score in the Z table. Looking up Z in the reference table. Okay. If the alternative has greater than, p-value equals tail area to the right. Alright, I'll just say the p-value is equal to the area to the right of Z. If the alternative has less than, p-value is equal to area left of Z. And if the alternative has a not equal, then the p-value is equal to 2 times the tail area. The tail area is always going to be less than 1/2. So if you look up your value in the Z table and you get a positive value greater than 0.5, you're going to subtract from 1 first and then multiply by 2. Okay? And then your conclusions will be, if your p-value is less than alpha, reject the null hypothesis. And if the p-value is greater than alpha, do not reject the null hypothesis. Okay? And this actually, finding the p-value and your conclusions apply to both hypothesis testing for one sample and for 2 samples. Let's talk about what you want on your note card for 2 samples. And the null hypothesis is going to be P1 is equal to P2. That's always going to be the case for hypothesis testing for proportions with 2 samples. The alternative will be P1 not equal, greater than, or less than P2. Your standard error is just given by this crazy formula, p hat times 1 minus p hat times 1 over n1 plus 1 over n2, where p hat is given by y1 plus y2 over n1 plus n2. Okay, so whatever count in your problem, you combine the total number of successes in sample 1 and sample 2, and you divide by n1 plus n2. Your test statistic z is going to be p hat 1 minus p hat 2 divided by the standard error. Okay, and p hat 1, of course, is y1 over n1, and p hat 2 is y2 over n2. And then same rules, your p-value is found by looking up your z in the reference table, and these rules still apply here, and your conclusions are also the same. So this applies to both 1 sample and 2 samples. It's just how you get your standard error and how you get your z test statistic or z-score differs. So keep that in mind. You'll probably want these formulas somewhere on your note card for this week's quiz.